Hello everyone, welcome back to my GCSE Python tutorials. Today I'm going to be going over the debugger in IDLE. It's an incredibly useful feature for finding bugs and better understanding what's going wrong in your code. You might not need to use it, but it's definitely useful to know about. So I'm going to start off by just making an example program for you. Okay, so here we have a program I've just made. It may look a little complicated, but it's not very bad really. Here we've got two subprograms. You've got multiply, which takes in two arguments. You should remember that from my 8th video on functions. Then it prints out multiplying this, which you should remember from my strings video, using a format string to put A and B in. And then it returns A times B. You should remember this from my operators video. And here I've got a second function that divides two things. Obviously these functions are useless, really, like you could just do that. I'm just doing this as an example. So I've defined my global variables here. And so what I do here is I say hello and I ask for two values and then I do some if stuff and then I print it out. So here's where the debugger comes in. Something I'd highly recommend doing just in general is showing line numbers. I'm not sure if I mentioned that before, but very useful. And then here on this one, on the actual running one, you click debug and then click debugger. And so all you can see is just print out this, debug on. So now you know the debugger is on. So let's try running our code with the debugger on. Right, okay, I wrote my code wrong. So now I've run this code, you can see there's some things going on, and I'll explain all these in a second. By the way, no need to copy out all this. You can if you want, but there's no need. So as you can see, there's lots of things going on here. So first of all, let's talk about this. All of these variables that have appeared with underscores and stuff, most of these you don't need to care about. What I'd recommend doing right now is enabling globals as well. And you see all of these things have jumped to globals. And globals is in global variables. So what's going on here is it is stepping line by line through our program and running each line as it is. So if you want to keep doing that, you just click step and you see and this is just it defining these. And if you want to see in the code which line's being stepped on currently, you click source and you can see it's highlighted here. And yeah, so it's processing this line. So if I step, now you'll notice A is here now, because A has just been defined here, and so it is a global variable. I've defined a variable and it's a global variable, so it's shown up in the global variable list. So yeah, like I said, you can ignore all of these basically, and these are just global functions you can access. This shouldn't mean much to you. So now, yeah, I can see the value of A at any point, which I think you can probably understand how that would be useful for debugging. You can tell if the value of a variable has somehow gone wrong and where it's gone wrong. So then I can just step through again and get all these. So now we're getting onto this line where it would print hello. And so let's see what happens if I step on it. So what's going on? Why is this opened? What's this? And I'm stepping through some other program now. And all these things have appeared. This, I don't know why they put this in the debugger, but what's happened here is it's quote unquote stepped into this print function. So as you may know, the way print works is it's calling a function in the same way as if you called your own function, like divide, for instance. All it does is call the function, but that function is in internal Python. So what it's done is it's opened part of the Python source code that does the printing bit, and it's now stepping through that, which is obviously not very helpful. Not very helpful for actually debugging your own code, because chances are the error isn't in Python source code, it's in the code you've just written. So I don't want this, right? I don't want to be in this. So what I can do is I can click out. And what this will do is this will simply step me out of whatever I'm in. And so you can probably close this now. Also, do note that that window wouldn't open up if you didn't have source highlighted, because it was just highlighting, it was trying to highlight the line it was running. It wouldn't have shown up if we hadn't had source on. But it's good to have source on because you can tell which line's being executed. So here we're just so now it's opened the code for input. We just want to step out again, and so you'll notice this keeps happening. We keep stepping into things we don't want to step into. So what we can do instead is we can step over, right, by clicking the over button. And so that means we won't step into it, we'll just step, over it, yeah. So we're on this if statement, step again. So we're on this if line. So do know if you're accidentally stepped into something, you might have to click out a couple times to get out of it if you're in many layers of functions or whatever. So if out doesn't seem to do much, don't worry. So here we're getting on to a line which runs one of our own subprograms. So let's just click step instead of over. So this is where stepping in becomes useful and not just a hindrance that means we get to jump scared by a load of Python source code. So if I click step again, you can see the code's jumped inside of this divide function. And then it runs the code in here, and yes, classic, stepping into the print function, out, and then it does this return. So that's where it's useful. That's the bit where it's useful to step into things. So it's pretty annoying having to click step each time. And that's only if you want to step through your code line by line. So what I can actually do is something extremely useful that programmers like me really love. It's a really good feature for debugging. I can set a breakpoint. So let's say there's an issue. I haven't put these ints in, which I definitely didn't do earlier by accident. So these are coming out as strings, but I'm trying to compare them with integers. This line of code is not going to run. So I set a breakpoint here, right? Because it will give me an error here because no string there. So what I can do now is I can simply press go, and then I have to do these because these input statements freeze the whole program. I'm gonna have to do these. So you see what's happened here is so what go does. Let's remove this breakpoint for a second and just refresh the program. If I press go, it will just run the program as normal. Right, I just type in all and you see I get to this error. But go, as well as running the program as normal, if it hits a breakpoint like this, you can see Python's highlighted this line because there's a breakpoint set here. It will stop the program. So I can press go, and then and then it will freeze here. And so we're back in this kind of step-by-step mode where we can click step and go through. But you see there's this error here. So now here's the useful bit of these things. Remember these? You can see A and B are actually being set to strings. So Python's type declarations are not very strict. So even though we've already set their numbers over here by saying they equal to 0, it just changes them to strings. It's like, oh, well, they're putting a string in it. So they obviously want it as a string, which is very easy to make bugs and a very good example of why this debugger is useful. So here we can see the values of A is not the number 4, like output is the number 0, but a string containing 4. And so we're like, we're not putting these the right type, put int statements around here, just like that, rerun the program, go, and I have to do the input statements. You can see it gets to here, no exception this time, and I can just step through. I'll step over this one. So if you're wondering what quit does, it just quits the program without closing the debugger or anything. So you can just easily stop the program. So if I'm like partway through over here, I can just it wants me to do an input, but then I can just quit there. So I haven't really explained what this is exactly yet. So this is what this stack is. It just means going through each line of code that's being run. You don't really need to know what the stuff before this means. This just means it's your program, which line it's on, which you can see that line lines up with the highlighted line here, and then just what code's actually being run. And do know, obviously, if you end up with a Python program that has multiple files in, it will tell you which file it's in, which is quite useful. Hypothetically, if you're stepping through some Python source code by accident, it will show you where it is in there and that sort of thing. So this is just a useful thing that tells you which bit of line is being run along with this. Yeah, so you set a breakpoint by clicking set breakpoint, and then you can get rid of it by clear breakpoint. Yeah, so that's the debugger. Really useful for finding bugs, as I showed a second ago. Obviously, that's a very obvious example, like this sort of thing happens all the time, and you could in theory get this from here, string in, but it does help. It does help. Because you can see, if you step through, you can see exactly what point in the code the variables go wrong, or the function fails, or whatever, right? And remember, stepping through lets you go into things. So just to summarize, there are these 4 tick boxes. Locals are just like local variables do something. So if I define a variable in multiply, like I don't know, this, and then I run the program. Yeah, so to show you what local variables are, I can just run the program as normal, step over these things quickly, and so then I just set it to some sort of value that will make it run the multiply code. And then if I step into multiply, you see I've defined this function now, and you can see in the local variable area we've got A and B, which are these arguments, and you've got this string egg, just because I've defined something called egg here. And if I step out of this, okay, leave me alone, if I step out of this again, you see they're gone, they're local variables, they only exist within these functions. So yeah, that's what locals are. So to summarize, there are these 4 buttons here. There's the stack, which is what line's being run. There's locals, which are local variables that only exist within a function or something. Globals, global variables. Most variables in Python are global. Only ones defined in subprograms are not. Also remember, in the globals tab, ignore all of this rubbish most of the time. Source, this tick box just highlights which code is being run. So now these 5 buttons. Go runs the code until it hits a breakpoint. And then stops. Oh no, I've set the breakpoint wrong. Go runs the code until it hits a breakpoint, and then it stops, and then you can step by step again. Step simply runs the code line by line, and it will automatically step into functions, even Python ones like this. So you'll get a load of code on your screen. And then following on from that, you've got the out, which if you're inside of a subprogram of any kind, you can just click out, and then you're out of that. So you see I've jumped from the inside of print out to the next line. And then over is just like, don't automatically step in, just do the line of code that's next, don't be clever about it. And then quit just quits the program without closing this tab. So yeah, that's about it for the debugger. Remember it, if you've got a bug, have a look at the debugger. It may help, it might not. There's no need to use it if you don't want to. It's useful to learn, definitely. There are lots of similar debuggers in other programming languages like JavaScript, the console and debugger in JavaScript, and most other sophisticated programming languages have a similar debugger to this. It's a useful skill for the broader scope of programming as well as this. As far as I'm aware, they won't ask you to use the debugger explicitly, but it could be useful for writing a trace table or something, because you can see what all values of every variable is at all the time. So yeah, so it'd be useful for a trace table or something. So yeah, to be honest, this video is based off of a video by RealPython, I think they're called. I'll link them in the description. Their video's probably better than mine. They've gone over the same topics as I have. So thank you all for watching. Go watch them after this. Slightly longer video than mine probably. And yeah, thank you. Goodbye.